Good morning. We can wait for few more minutes. Only 16 candidates turn.
Okay.
There are 31 candidates. Shall we begin now?
Yes, I think we can start. Let others join on.
Okay, we are entering into the seventh session of this program. Our resource person, Professor Vishnu Nambudiri, has joined us. I invite him to this session and request him to deliver the talk. And I also welcome our resource person, Professor Vishnu Nambudiri, and all of you to this session. Okay.
Good morning to all of you, and thank you very much, ma'am. So we have been discussing in detail about the Python module symbolic Python or sympy for last I think 2 days. Today we are going to enter the intersection of two modules, in fact, which is symbolic Python as well as matplotlib. So symbolic Python, we know that we can create symbols. Just 1 second. Yeah, symbolic Python can be used to create symbols, and plotting is nothing but placing XY points on the plane so that it will finally look like a curve. That's what essentially we mean by plotting. So the plotting function available in Python is available actually in different libraries, and even though most of these share common features, certain times what happens is that we may get confused with what type of plotting function we have to use from where. So anyway, we are going to use the plotting function available in symbolic Python library, and in between we will shift, if required, to the plotting function available in matplotlib. Matplotlib simply means a not mathematics plotting library. Metrics plotting library is the expansion of matplotlib probably. So we are going to use these plotting tools, and we will see how to plot graphs using the data that we are generating using the programming language Python. So we have seen previously itself that if we had attended the workshop in LaTeX that the Calicut University conducted 2 weeks back, you might have seen that in LaTeX we can create beautiful graphs and high quality graphs in using Python. But in the problem with LaTeX is that the limit that the software LaTeX is not actually a programming software, and therefore it's highly limited in drawing functions. Other than standard functions, it may not be able to so quickly, so easily draw graphs of functions. But in Python, the good thing is that we can define arbitrary functions to our liking, and we can construct graphs. Okay, be it continuous, be it discontinuous, all these things we can create using Python plotting function. So we are going to start discussing the plotting capabilities of Python. Of course, we will be discussing only the limited part of the plotting capabilities of Python, because too many libraries, too many functions are available in Python, so that we cannot completely discuss any of these things, and we don't require also. So whenever someone wants to find out some particular type of plotting, he or she can directly go to the Google website and search for such a functionality. The answer will be already available there, because Python is such a popular language. Answers can be found immediately from the internet if you want some specific type of plotting, specific function to be plotted. Okay. So we are going to start a new program, and as in the previous sessions, I will be sharing the Google document link with you, from where you can copy and paste the Python code to Colab or your own local installed Python IDE. Let me start. Let me share the Google document link first. I'm creating a new file for today's code. So So the link is here. Okay, let me start sharing my screen. Okay, so today we are going to start something related to plotting. So plot basics, let me give the name as this, saving the file as plot basics once again. Okay, to yesterday's document, Google document link I will share. Please remind me after this lecture. I can find out that link and I can share with all of you. Okay, so we are going to import the function called the plotting function from the symbolic library, symbolic Python library once again. So, in fact, the plot function is actually available in a larger class of functions called plotting inside SymPy. Okay, it is not directly in SymPy. The plot function is not available directly inside SymPy, but there is actually a library called plotting inside SymPy. Inside that, the plot function is available. These things are named as classes, objects, all these kinds of technical things we don't have to worry about unless you are very much interested in going inside, going into the deepness of programming. If we are interested only in using Python as a tool, we are not interested into what do you call entering into the deep sea of Python and going into the depths of Python. Don't worry about these things. Just use the plot function from sympy.plotting module. That's it. So let me start. I'm importing the plotting function first of all from sympy.plotting, not directly from sympy, but inside sympy there is something called plotting. Import plot. So this is the very first command. Okay, now we need to create symbols. Without symbol, we cannot use sympy at all. Symbol or symbols, whatever you want. Let me define x as a symbol first. Since there is only one, we can even import the capital SYMBOL symbol. Now the plotting is quite straight. Plot. Plot x. Suppose what will happen? Let us see. Okay. The plot is appearing here, and see that the range of this plot is automatically taken to be from -10 to 10 automatic. And what happens actually is that SymPy is making use of the matrix plotting library or matplotlib, and therefore most of the functions are the same, but there are certain exceptions. There are certain changes the way in which the plot is used in SymPy. Once you import plot from SymPy or you import plot from matplotlib, there are certain basic differences. I will try to show those differences after some time. So this is how we plot a simple graph. So this is just x. This is y equal to x. Plotting x essentially means that plotting f of x. So the function is nothing but f of x equal to x or y is equal to x. Okay. Now, in addition, if you want, see one more thing, we need to remember that suppose that we put plot x square. Let us see. So that both these things are plotted. Plot x square, plot x. Both these things are plotted once again in the range minus 10, 10. Now, can keep on doing this. Plot 2x plus 3 or even sin x. Remember that the sympy cannot be probably used along with the sine cos functions available in the math library cannot be used for plotting here because sine and cos we are going to put x as the argument, which is a symbol. The math functions sine cos in the math library, if you are importing sine cos from math, it will accept only numerical values are their arguments. Symbolic the symbols are not accepted. So you need to be really careful. You need to import sine and cos from sympy. Otherwise, it may create something. Okay, let us try to plot sin x first. Is there any the sin x is appearing here? Now let us see sin x plus cos x. That's a function. On the other hand, plus. Okay, let me just try to show that instead of sin x plus cos x, let me try cos x. So what is the meaning of addition of plots? Oh, here it is not working. Sorry. Doesn't seem to work here. Maybe I can just put a comma here. I'm just trying, experimenting. It's working. Sin x plus cos x is sin x and cos x in the same graphs, in the same axis. That's working. But the only thing is that there is no color difference, so it's a little bit difficult to identify that what corresponds to what, which is sin x, which is cos x. It's a little bit difficult. Of course, there are ways to solve these problems, but we will try to see. We will try to see more and more options, more and more plotting, and after that, we will try to look at this. Okay, now suppose that we want to control this plot. Suppose that we want to control the x values of the plot. So if you want to control the x values of the plot, what you need to do is uh, enclose the plotting functions in one bracket. If you are drawing multiple functions, enclose all of them in one single bracket. After that, define the range of x. Suppose pi is not important. Suppose we import pi also. Suppose that we do it in the range minus pi to pi. Closing bracket. Trying. Cos has no length. What is meant by cos has no length? X in the range minus pi to, what did I do? X. Let me try to say that. Sin x and cos x I have already plotted. Is the mistake here? Maybe pi is not there. Okay, pi is there. So sin x and cos x I am plotting with x in the range minus pi to pi. What is the problem? Line 29, check arguments x minus pi pi. Object of type cos. Okay, let me just try to remove one of them and see after that. Is there any mistake from? Okay, this is perfectly working. Why multiple things? Okay, let me try. Oh, okay. Therefore, this is not required to be enclosed inside one one bracket. So sin x cos x, and after that enclose the variable, enclose the range of the x variable um, as a tuple, as a three tuple. The first is the variable name, second is minus pi, third is pi. The first is a symbol name, in fact. So it's appearing in the range minus pi to p. You can see that this is to the left of minus 3, it has gone. I don't know whether I can increase the size of it. I don't really think that I can increase the size of this. Maybe if I draw it here, even then the size is not very. Maybe I need to. Okay, I hope that you are able to see the graph at least. You are able to see the graph at least, I guess. So this is f of x. It automatically shows it to be f of x, and the sine cos graphs are appearing here on the same axis. So we can plot most of the functions like this. And suppose that if you define, so which function we should plot? Suppose that we define the greatest. Okay, you can define piecewise functions also. Okay, piecewise functions. So piecewise function in the sense that just you can define a function to be having some particular definition in one particular interval and some other definition on some other interval. Okay, that also can be done. So for example, define f1. I'm defining a function f1 like. So suppose that I want to define a function which is sin x in the range minus pi to 0, and suppose that it is equal to sin x in the range minus pi to 0. So what happens is that at 0 it becomes equal to 0. From 0 to pi, suppose that it's equal to x itself. Okay, so the definition that I want is f of x equal to sin x in the range minus pi to 0, f of x equal to x in the range 0 to pi. Okay, so how do I define that? So I need to just return. What should I return? Return. Okay, I have to import. I need to use sin x and x here. So let me import. See, there is a small problem that if you are importing a function inside, if you are importing something from sympy inside a function, that may not be accessible to what we have for the purpose for the use outside that function definition. Such a possibility, such a problem can be there. I have not tried. I guess so, because this is the common experience if we are using some programming languages that whatever function, whatever variable you are defining, whatever function you are importing, that is local to the place of calling it, place of accessing it. So if you are accessing, if you are importing something inside some particular block, that will be usually accessible only inside that block. I don't expect to know whether this is the case with Python or not. We can try. We can try to say that. But anyway, I'm just saying. So it's always safe to include the import sign definition once again inside f1 of x, even though we have already imported that. Okay, that's what I want to say. Even though we have already imported sign outside this definition of f1 of x, it's better to import it once again. There is no harm. Return. What should we return? Uh, x itself. Sorry, sine of x. Okay, maybe then sine of x is a variable. X is a numerical value here. Return sine of x if uh, or otherwise we can use the normal method if x what should I do? Greater than. Oh, then pi also needs to be written. Pi. If x is greater than minus pi and x less than or equal to 0, what should I return? Return sine of x. On the other hand, else if so we want the definition to be greater than 0 and less than or equal to pi. Return sine of x. So this is the definition we have. I don't know whether it will work. We can just see. So suppose that, okay, let us try to see this function first. Let me just suppress these plots. And let this definition be there. Suppose print f1 of -1. It's going to be equal to sine of -1, correct? F1 of 0, it's not evaluating, doesn't matter. 0. Maybe we can ask for the numerical value. Yes, it's coming. What about sine of plot of 1? F1 of 1. Oh, here it is x, not sine x. Sorry. Okay, this function seems to be working anyway. So let us try to plot this. We have the problem actually with the plotting, if it's going to work or not. Okay, plot f1 of x within which range minus pi to pi. Let us, okay, but in that case the plotting should come below this. No, it doesn't seem to work here somehow. Okay, why is it like that? Let us see. See, this is actually a basic problem that most of the function definitions in Python assumes that you are using a numeric variable, not symbol. Okay, but now how do I define? Okay, there is some problem with the way in which we are trying to define this. So,
Sir,
yeah,
is it necessary to write the import command in the function body?
that's what I'm saying. The problem is that I'm thinking in two ways. One is that if you are using the import command outside the function body, the problem is that if you are moving the function definition to somewhere inside the program itself, suppose that you move this to the top. Okay, suppose that you are moving this to the top, then the function importing is happening after this particular definition. In that case, there may be an error. That's one thing. Suppose that you are
Okay.
keeping it here, then there can be some error if you are not using that import. That's one thing. Second thing is that it is always a good practice to include all kinds of definitions, all kinds of importing that a function requires inside the function itself. It's always a good practice, because why I am saying is, otherwise you will actually get confused that if you have actually imported such a function or not somewhere else.
Okay.
There is a possibility of confusion. So it's a good programming practice, is what I'm saying. Even if it's not required, sometimes it may work also. It may work also. I don't exactly know. It may work. But in the case of C programming and some other programming languages, some old traditional programming languages, this will not work. If you are not importing inside the function definition itself, it will not work. But here Python I have not tried, but still I believe that this is actually a good practice. We can
Okay,
try.
sir.
We can try to remove that and try to see that, but I believe that this is actually going to be good. Okay,
Okay,
now,
sir.
okay, thank you. Now the question is that, so the problem here is that here we are defining x to be a symbolic variable, and inside the main program we have defined x to be a symbolic, it's a symbol. So we are trying to pass symbol as an expression. Okay, that's actually one problem. Maybe, I don't know, how should I do that? Return sign of x greater than or equal to minus pi. But here I am trying to evaluate, uh, cannot determine truth value of relational, cannot determine truth value of relational. So to solve this issue, the problem here is that when we are trying to draw something, when we are trying to plot, x is here treated as a variable. X is here treated not as a variable, x is here not treated as a variable, x is here treated as a symbol. That's the problem. Okay, net, if we okay, let me just try to see once again. So this problem is happening only if we are trying to define our own function. See, the sign function defined inside sympy is compatible with the non-numerical symbolic expressions. So there is no problem at all. Okay, otherwise, is there any other way? I'm just searching. So we have symbol x. Suppose we define, uh, so I think this is not going to work. Okay, I'll try to find out an answer for this. There is an answer in the internet I can find, but it's a little bit complicated. And for even using that answer, I think I need to just what do you call? I need to just make use of the numerical Python array. That's a method suggested somewhere. I can try to give an answer after, maybe in tomorrow's lecture. I can try to give a complete answer to this. That defining a function, defining a piecewise function using symbolic expressions and plotting that. That's the question that we are left with. Okay, for the time being, I'm just dropping that question. I'm just keeping this in pending. Okay. Um, Otherwise, we are unable to evaluate it. That's basically the problem that we are finding. So defining a conditional function, that's the problem. Okay. So otherwise we need to create a list of points using this, but list of points is also okay. That is something called list plotting. Okay, anyway, we are proceeding. Just dropping this. Okay, let me update this first of all. So this particular part I will suppress for the time being. Maybe we will take it up once again tomorrow, since I am not able to completely tell what exactly to do in this particular situation. I'm just suppressing this for the time being, enabling the other things. Okay, let me just see once. Okay, let me update the entire thing except this. I will give you a complete answer tomorrow. Let me update the Google Sheet first. Okay, update. We can try. Sorry, I have. Okay, now let us move to create another program. This program is not complete. So what we have discussed is that how to give access and how to give the range of x in plotting that we have discussed. Now let us try to add more options into this plotting. Same function we will try with. So let me just add a few more options to this. So the same sin x and cos x, or maybe even x square. So we can add some title also to this graph. Okay, we can add titles also to this graph. So we can add to the x-axis, we can have a label. All these things are possible. Let us try to do one by one. X label equal to the x label. I'm putting as, maybe simply I will put it as x-axis. Let me see the effect of that. But not that already the X symbol is appearing here. Okay. But instead of that X symbol, now it has become X label. But since we have not given any Y label, it's automatically appearing as f of X. So if you want to give the Y label also, we can put Y label, Y axis. So X axis and Y axis are appearing. Now to this graph, we can put a title also if required. Title is, maybe we can give this X square. The X square is appearing here on the top. I don't know whether we can put some LaTeX title also. I think so. Let me try. No. Okay, LaTeX. I need to use this symbol. Yeah. So we can use LaTeX title also in this. We can give in dollar symbol. If you want to use some expression, you can give in dollar symbol that particular expression, and that will be appearing on the top. Or you may even give this is what y equal to x square. So all such options are there. So we haven't covered all the options. We have seen only a few. Let me update the Google document with this. Done. Metron. So see that this is not like what we actually do in the case of plotting inside LaTeX. Plotting in LaTeX was using PS6 or ticks, but there the defining functions and all these things were highly limited. Here we can define any type of functions. If we need, we can define our own functions. Though we have not succeeded just now in plotting that particular function, I guess that we will be able to do that. Maybe certain things needs to be fixed, and I will try to find out that, and I will tell you tomorrow that how to exactly do that. Plotting arbitrary functions, plotting our own defined functions. Okay, so these are some options. Now we have more. Suppose that we want to save this. Okay, suppose that instead of plotting on the screen, suppose that we want to save this file for including in our LaTeX file or wherever we like. So instead of showing it directly to the screen, we can save this to a variable p equal to this and show equal to false. And instead, so what will happen here is that it will not be shown. Okay, let me just suppress this. The graph with the x label, y label is not shown here. Now, how do we save this? So now this is stored in the variable p. So p save. Now we should give the name of the file to save. X square graph dot png, or I think png is the default format using which you can save. So wherever this particular file, wherever this program is located in the directory, there this file will be solved. This particular picture will be solved as this file. Okay, in quotes. Here if you are using Google Colab interface, you may not be able to save it as a picture, is what I think. For saving it as a picture, for using directory related things, you need to use Python installed in your system. Okay, Python installed in the Google Colab interface or CoCalc interface may not be probably able to save it as a PNG file if they do not provide file level access. Okay. Now we can give more, there are more options. So this is one way. Suppose that we want to change the color. Suppose that we want to change the color. I'm just removing these commands. So plot, let it be here. Let's directly show that. Now I'm concentrating only on the color aspects and line style aspects. So show is equal to false is removed. Now let us try sin of x. So this is stored into P. Now, suppose that we want to change the line color. Okay, line color can be changed into, I think there are a few options like blue is supported, red is supported. I think there are some color codes. Okay, of course we can find using the help on plot. Suppose that we use the help on plot. Okay, let us try to see that. Help plot. So this is the help on plot, which is automatically available here. Plot. There is the color option. So these are all the options available with plot. Expression 1, expression 2 range. Expression 1 range, expression 2 range. This is also possible. That means that for one particular function we can have one range and the other particular function we can have another range. Arguments show, by default it's true. Depth, NB points. Okay, line color. Okay, this is appearing in a larger library, capital PLOT. Anyway, let us try to set some color for this. See that now this is saved. Not this one. Now this is saved to the variable P. Now setting the line color. Suppose that we plot x square also simultaneously. So now there are, x square, the range we need to probably specify because the range is becoming too large. From -100 to 100, why is it taking like that? Because I think it's essentially because if we take x from -10 to 10, x square is becoming 100, so uniformly it's taken. So let us not do that. Let us take x in the range -pi to pi and see. Okay, -pi to pi, even if we take the y range is becoming too high. So let us take it in the range 0 to pi by 0 to pi. That's enough. Okay, so now there are two plots. Remember that there are two plots. One is the sin x plot and other is the x square plot. But these two are stored in P in different ways. Okay, for example, so we need to suppress the show equal to also. Show equal to false we should put, otherwise it will be automatically appearing. Now suppose that the color of the first one, which is sin x, we want to change. So P0, the first one is accessed using the command, using the line P0. And P0, let us change the line color. Equal to, say, blue. And P1, say the line color to be red. And now show P. Okay, this is one option. I think there are many ways to specify colors. This is also possible. Red or even black. You can specify even like this. This is B corresponds to, sorry, black is actually nothing but this is for the short name for black is not B but K. This is K. You need to check the documentation for all for getting all kinds of colors, and you can specify the line style also. Line style we define line style. Suppose we define it to be dash. I don't think that the dash is working, so let me see with something else. Oh, even that's not getting P line style. I think it's not supported in the plotting library available in sympy. It's available in matplotlib. Okay, we will try to see matplotlib also together with this so that we can have more options. Okay, let us try to put some legend instead. Legend. Okay. Legend means that in the graphs you might have seen that this particular color, this particular some color will be shown and it will be displayed that this color corresponds to this particular graph. So for that we need to turn on legend. You can see that on the top here, sin x is appearing, sin x is written here, and x square is also written here. Sin x is written here in blue, and x square is written in black. Line style, I think line style I would have used in this way. Okay, just try. Oh, even then it's not working. Okay, can we use this? Is this dashed? This is not dashed anyway. Can I give it along with this directly? I don't think so. In that way, it will be affecting both, which is not probably what we want. No, this line style is not working in plotting in. Okay, we will try to see it using. We will go to what you call the matplotlib directory, matplotlib plotting library directly, and we will try to see more options instead of trying with this sympy plotting. Of course, sympy plotting is actually using matplotlib plotting itself, but as I told, there are certain restrictions. Some few options have been taken from this matplotlib to be included inside the sympy plotting. So that's why we are getting only limited options. Otherwise, matplotlib library is very rich. We are not getting all the options. Okay, let me update the entire thing once again to Google Sheet. That. Please try. Okay. Now we are abandoning this symbolic Python, and we are now going to make use of something called what do you call a numerical Python module. We are going to, so that numerical Python module as well as the matplotlib library we are going to make use of simultaneously for plotting. Okay. So numerical Python is it's a very powerful library available in Python for most of the numerical programming related needs. Numerical Python library is essential. So let me start a new program. We will try to do all these things. Whatever we have tried to do here, we will try to do all these things using the matplotlib library and numerical Python module. Starting a new file, plot matplotlib. Okay. So the very first thing that we have to import is the numerical Python library we need to import. Remember that the basic one problem with Python is that many of the mathematics functions are related in many libraries with the same name. For example, the sine function that is defined in the math module, it's defined in the complex math module, CMath, it's defined in symbolic Python module, SymPy, it's defined in numerical Python modules. So all these functions have different capabilities, and symbolic Python defined sine function is not compatible with numerical Python related structures. Okay, symbolic Python uses symbols. Something special that's coming out of this symbolic Python library is symbols, but that symbols cannot be used along with the numerical Python sign function. So such problems are always there. So, but most of the times when people want to do some plotting, they use numerical Python clubbed with matplotlib. Okay, that's a standard. So symbolic Python, I just tried to introduce, but the limitations we have seen that many of the options available in the matplotlib library for the plot function is not working in this symbolic Python provided plot function. Okay, so we are going to we are going to explore, we are going to find out the full capabilities of the plot function available in matplotlib, directly importing it from there. So let us import something from numeric Python from numpy. That's the name of the module. Import sine. Okay, here, in the case of symbolic Python, what happened previously was that we simply specified the range. Okay, the plotting happened in that range. So, how the plotting happens is something that we should understand. So, the computer programming, so the software finds out some sample points. It takes some points, more or less evenly distributed from the range. It finds out the corresponding y values, and it tries to put x and y, x comma y, the ordered pair of points. And after that, what happens is that the points are connected using smooth curves. That's how plotting is usually done. It's not true that even if we do plot in our own notebook, we are not finding all the points on that curve, and we are not connecting all the points. We are taking sample points. In the case of symbolic Python, the sampling of the points are taken care of by symbolic Python itself. But in the case of matplotlib and numeric Python, we need to specify the points to be used for connecting the points. The points to be used for drawing the curve, we need to specify. Okay, that's the important difference. So suppose that we want to plot the sine function. Suppose that we want to plot a sine function within the range minus pi to pi. Now we need to find out points in the range minus pi to pi. So for finding out points in the range minus pi to pi, we need to use a function called a linear space. So linear space essentially means that find out certain number of points within that range. Okay, so we are going to essentially create x coordinates. X coordinates equal to, or let me import linear space also. Let me import pi also. So minus 2 pi to 2 pi 100 points. Equally spaced. This is what I'm doing. So x coordinates are now here. So if you want to see the x coordinates, you can try a print. See this? These are the x coordinates, starting with minus 2 pi, ending with 2 pi. So how do I form what type of data this x coordinates or x coordinates variable is holding? Is it a list? Try to see that. See that this is a n pi nd array. Okay, the return value of the linear space is something known as an array, nd array. Probably a numerical decimal array. I don't know exactly the meaning of that, or n-dimensional array, or maybe even n-dimensional array. Suppressing. I'm seeing it if you require. Now we need y coordinates. How do we create the y coordinates? Y coordinates can be quickly created because the sign function in numerical Python can act on nd arrays. Usual sign function can work only on one numerical value at a time. Here, the symbolic Python provided sign is not like that. It can act on multiple values at a time. It will provide exactly the same type of value return. For example, suppose that you are applying sign on 5 values, the correspondingly sign value of 5 values will be provided simultaneously, like this. Sign of x coordinates. No need to apply it one by one. Now maybe we can print even the y coordinates. Printing. These are the x and y coordinates. Now the plotting needs to be important. So we are not going to import the plotting library alone. Let us import see here, instead of importing it like this, we may import even okay, import. We don't recover everything in matplotlib matrix plotting library. Import pyplot as PLT. This is actually standard, so that we can use PLT everywhere. Instead of using matplotlib pyplot, we can use PLT everywhere as a shortening. So just like that, most of the times for importing numerical Python as a whole, what happens is that import numpy as NP. That's a standard. So wherever instead of typing numerical Python numerical in numpy all the times, we can simply type NP, and we can use np.sign, np.linear space, etc. Okay, what I wanted to say is something like this. So suppose that we use import np. Then after that, you need to use np dot numerical Python dot np dot. You can do like this. np dot. This is to avoid the confusion that your sign function is coming from where. It's from, especially if you are clubbing symbolic Python as well as what you call numeric Python, then you need to be really careful which sign function you are using. You need to clearly know. So in such a situation, it's better to use this NP format. So PLT is important. Now, how do we plot is we use the plot from PLT. The plot is now inside mat. So the plotting function is actually available inside matplotlib dot pyplot. Okay, plotting function is actually available in matplotlib dot pyplot. Okay. Okay, we plot plt dot plot. So here we need to specify the x coordinates as well as y coordinates. They will be connected. We are not specifying any function here, but instead of that, we are computing the coordinates, and we are explicitly giving these. Now, even after that, the plot will not be shown because show is tend to be true automatically in symbolic Python. Okay, but in matplotlib, the plotting show is not turned on. It's by default it's false. Plt show. So whatever is plotted, show it. Done. It's inside a frame. Okay. So we have all the options that we have previously used even available here. Like let us try to put some extras here, giving some x label, y label. But all these things should be done before plotting. Okay. Plt dot x label. Here there is no axis. Okay. Here there is no axis. You can see that by default there is no axis. Y label. Y x. So x is appearing here, y is appearing here, and title also. I don't know. Title must be given like this. Sin x, it's appearing. All this is service. Okay, let me update the entire Google document, entire program, the Google document. Updated. Once again, using save fig command, you can save it if required. Now, multiple pictures also can be drawn like this. So now suppose that I draw one more. So how do I draw? Okay, let me just save this as a new file. with more options. So suppose that we have x coordinates here the same, y, suppose that we apply sine as well as cos, and we will try to see that what are the things that we can do on multiple graphs. Y sine coordinates we will put instead, and cos. So that, which essentially means that we are applying sine and cos. So in B, cos, sine, cos x. So we need to plot two functions. So this is not required here. X coordinates is also not required here. Now the essential thing is that we need to plot sine coordinates as well as cos coordinates. So let us plot this first. Let us plot this next and see how is it appearing. So that here, unlike in the case of sympy, the colors are automatically changing. And we can even give some labels here and turn the legend to be on. Okay, for example, suppose that here, where are we drawing? Sine coordinates are drawn here. Suppose that we give the label of this particular graph. We want to put some, we give some legend here. The label is sine of x, suppose. And for the label to appear, legends should be turned on. This is cos of x. And let us turn on legend and see the output unmatched. You can see that the legend is also appearing here. Legend is nothing but the sine cos descriptions appearing here. Okay, let us try to see if line color can be changed here. I'm just trying. Line color equal to red. Try. Oh, not appearing. No. Okay, just red is enough. It probably understands that the third coordinate is going to be equal to the color. But how do I specify? How do I know that I am giving the color itself? Okay, let me just try one more thing. The line style, let me just change it if it's working. That is not working. So what's happening here? X coordinates. Maybe I should give it simultaneously. Okay. So this is working. R double dash. So that means that in red color put dashes. If I put a single dash, that's a straight line. If I give R O, there'll be dots. C O, C for cyan. So this is a dot and connect them using this hyphens lines. Okay, such changes are possible. Such modifications are possible. Giving some color. So we can draw multiple graphs on. So here we have drawn actually one graph on. We have if we are plotting, suppose that we are plotting here, we have plotted how many graphs? Here we have plotted two graphs. But now suppose that we want these two graphs to appear on different axes. Okay. Suppose we want these two graphs to appear on different axes. Here, what's happening is that everything is appearing inside the same plot. If you draw it again, what will happen? Oh, this is appearing multiple times. That's true. X. Where is the X? Okay. After showing, what happens is that it's becoming a new graph. After showing, it's becoming a new graph. For example, suppose that we want to draw instead of can we take x square instead? I don't know whether it will work. X square. So suppose that we want to plot a function like suppose that we want np. Suppose we raise it to the power of 2 so that x square will be plotted. X square. So the function that the power function from numerical Python can be used, but otherwise the problem is that if we have x coordinates for finding all the squares inside this x coordinates, either we need to use some method, because x coordinates is not just one element; it's actually a number of elements in that x coordinate. So either you need to what you call individually take the power of x coordinates each and everything, or we can directly use np power method. NP power, numerical Python has a function called power, which will give you the power of all the elements in the x coordinates in one stretch. Okay, x square. It's not here. No, the question is that suppose that we want the pictures can be actually made to appear side by side also, or even inside the same plotting we can make it appear below if required. So for example, there is a feature called subplot in this, so that we can define a matrix. We can define a matrix like 1 1 1 2 2 1 2 2, and we can arrange plots in these positions. So we can have first plotting appearing at 1 1, second plotting appearing at 1 2, third at 1 3, fourth at third at 2 1, fourth at 2 2. So that method is known as subplot. For example, suppose that we are plotting this function. Okay, let me just start a new file for subplotting. Let me update this first in Google document. So this is updated in the Google document. I'm starting a new file for subplots and more options. If 5, oh, this is in fact 36. Okay, there is some missing in the numbering seems. Anyway, plot subplot. So our plan is to define a matrix like 1 1 1 2 2 1 2 2 and plot graphs at these positions. Exactly the same commands we are going to use. Import numeric Python. Saving it. So 33, 34, 35. This should be 36. Okay. Suppose that we are going to plot tan, the tan function, or maybe even x square, x function, x square, x cube, etc. like that, or sine cos, something similar to that. X square, let us try to plot x square np power x square, now x cube. Okay, now importing the plotting function, now trying to plot but as subplots. So this is an essential command all the times. First of all, we need to decide that what type of metrics we are trying to look at. So let us place this at, let us define the number of rows and number of columns to be 2 to each. Okay, 2 by 2 matrix, in which this is the first item. Let the label also be there. No need to worry about it. Just forget about this. Legend. Do not use show. After that, let us define the second one. So, what are the coordinates? Sine coordinates are already there. Now, the second one is legend. Let us turn it on for each and every. So, for the second one, see, we are essentially plotting 4 functions, but we are showing it on the same what you call same plane, and they are arranged in rows and columns. That's the only thing. Otherwise, they are all different graphs. But the good thing with this is that you will be able to compare quickly. You don't have to draw the graph multiple times. You need to again arrange it into rows and columns. That's not necessary. Python itself will draw and show it to you. So course is here at This is the second graph out of 2, 2. Now third graph in 2, 2. Third graph is nothing but square root, square coordinates. X square, lattice chord. Here the lattice chord, I don't know it will work. Let us try. In label it's definitely working. Title also should work. I think we have already tried that. 2 to 3 and finally 2 to 4, which is the cube. But everything is appearing in the same color. Okay, doesn't matter. You can see that sin x is appearing here, cos x as the second one, x square as the third one, and x cube as the fourth one, using subplots. Of course, you can control the colors. Blue dot if you want, then see it. Making it more colorful. Cyan square. Now, squares are very close, so you cannot identify it to be square. These are squares in x cube. And you can save the figure either as if you want, you can save the figure without, instead of showing, you can save it like plt, save fig. JPG, say, and with DPI, dots per inch resolution. Specify it to be very large if you want to include it in a file where it's going to be enlarged. So you can even do that. Or if you are saving it as a figure, you should suppress this float show. Both will not work simultaneously. Either show it or save it. Now, instead of that, if you want to, here what we have done is that for plotting, we have taken some specific list of points. Now, if you want to plot using our own points, or one more thing. So here we have used linear space for finding points. Linear space was used essentially for creating equally spaced points. But instead of equally spaced points, I think there was a question previously that how to find points at some specific distance which is not integer. Okay, if we want to use non-integer distances, we need to use something called instead of range, we should use a range. x coordinates equal to np a range from minus 2 pi to 2 pi at a distance of 0.1 say. So the points will be created from minus 2 pi to 2 pi at a distance of 0.1. So the function to be used is a range. So this is an equivalent of this the version corresponding range. In range, the increment can be only an integer, positive or negative. But in the case of a range, it can be a decimal value. So this numeric Python module is very powerful. If you are for all kinds of numerical computations, we need to definitely use numeric Python. There is no other way. Okay. So now, what was the question that you have asked? Okay, even before going to that question, I would like to give you one interesting example, which actually tells you that you need to be really careful about certain types of plots. Okay, you need to be really careful about certain type of plots. I will give you an example to show that. We all know the greatest integer function, right? You're all very familiar with the greatest integer function, which is in Python language. This is termed as the floor function. Okay, in Python language, the greatest integer function is usually called as the floor function. Let us try to see one plotting function that will tell you that why you should not blindly. Okay, let me just start drawing a function. to understand what I exactly mean. So this is 37 plot. Okay, suppose that we want to plot import numpy here. Suppose that we are trying to plot what you call the greatest integer function, which is the floor function. So let us create the x coordinates are already here. Maybe we can use within the range. Suppose that 0 to, suppose we take 0 to 10 with a distance of 1. Okay. So now greatest integer function. So greatest integer function is to be taken as floor. Let us try to plot it and see. Plot show. Okay. So what are the things that we have done here? Greatest int coordinates are here. The function is floor not there? NP, let me say once again. The function probably is seal. Let us try with ceiling instead of floor. Value error. No, the error is not there then. Value error floor. Where is that error? Okay, let us not do this now. For the time being, let's keep it here. Okay, you can see that the floor function, the graph of the floor function, which one I used? Floor. Okay. The graph of the floor function is appearing something like this. The graph of the floor function is appearing something like this. So, do you really think that this function's graph is correct? Anyone can answer. Do you think that the graph of this function is correct?
No, sir.
We know that this graph is not continuous, right?
It would be step function.
This is not a continuous function. Therefore, this should not be actually continuous. But you are getting the graph to be continuous. This is because what's happening is that, as I told previously, that whenever we ourselves or a computer software is trying to plot a function, what happens is that some sample x coordinates are taken and correspondingly y coordinates are found, calculated, xy points are plotted, xy points are connected. That's how it's working. Here what happens is that we have chosen some points. Okay, we have chosen some points, and according to those points, corresponding to those points, we plotted. That's it. Those xy points we plotted simply. That's it. That's not correct. Xy points cannot be connected like that. That's the problem. So this is how computer is drawing. Not computer. We are also drawing like that. And one more thing is that if you reduce the number of points, Suppose that we reduce the number of points. Here we have taken number of points at a range of 0.1. Here itself we can say that the graph is slightly what you call slanted. So the lines are slightly slanted. Suppose that we take more points, because we have taken only points, some 10 points we have taken within an integer range. So 0 to 1 we have taken around 10 points, 1 to 2 we have taken 10 points. So let us try to change the gap to 0.1 to see it more. Now this is looking a little bit more meta, but still it's looking like number of steps we are plotting, but that's not correct, right? Number of steps we cannot plot, because integer greatest integer function, we know that it's a discontinuous function. We cannot connect them, but here the computer is connecting it. So therefore, the most important thing to understand is that the computer software, you should be really careful when you are trying to draw some function where some complications can actually happen. So if you have a function which is uh, continuous, making it better, which is continuously differentiable. Derivative is also continuous. Maybe even the second, third derivatives all are continuous. So if you have functions which are very well behaved, then only you can expect the plotting to be somewhat better. Otherwise, don't expect the plotting to be very good if you have a function which cannot be trusted like that. You need to be really careful. So now the problem is that you have points of discontinuity. Okay, points of discontinuity you need to handle separately. That's all. But how do we do that? Points of discontinuity, how do we separately handle? The thing is that either you should locate yourself. In the case of in integer part function, you clearly know that there are certain points where this is happening. So either you can define, that either you can define certain points where the function does not exist. You can exclude those. That's possible. You can exclude such points, or you need to divide the function into several blocks. If the points of discontinuity are very limited, then you can define the function in such a way that at those points of discontinuity you do not plot anything. That's one way, but it's really difficult. That's really difficult. Okay, so to avoid this, let us try to see how to avoid this cleverly by doing something. So to avoid this, what we can try to do is probably that we need to check the difference between consecutive points. If the difference between consecutive points is too much, what do you mean by too much? So here, in the case of greatest integer function, what happens is that the difference between the function values at 0.9 and 1.1, the difference between consecutive values is 0.1 and 1.1. That's too much. Why it's too much? It is not negligible. So you cannot connect simply. At 0.9, the greatest integer function gives you 0. At 1.1, or even 1 itself, the greatest integer function gives you 1. So the gap is too much. So in case you can make an estimate of how large the distance is going to be in case of discontinuities, there is a way. Okay, in case you can determine how large the discontinuities are going to be, there is a thing. That's the only thing I want to say. But if you cannot even determine how large the discontinuities are going to be, then software itself may not be able to determine, because software is not cleverer than you. Okay, software can do repeatedly things. Software can execute things much faster than you probably, but it's not. Its logical strength is not greater than that of you. Okay, so we are going to use a function. We are going to use a function called. We are going to actually make use of a few extra functions from numerical Python. The extra functions will actually allow you to locate certain points where the discontinuities are actually happening. Okay, let us try to make use of that. So trying to sort this. Okay, I'm keeping this file exactly as it is so that we can see that this file is actually problematic. Now we are trying to solve it. New file. Have I updated the previous file? No, I haven't. Let me update the Google document with this. This is a very interesting example. Okay, I have updated the Google document. Now I'm starting a new file. So handle discontinuity. That's what we want to do. We try to do. So all these things, let it be exactly like that. But now we need to do something extra. Okay, we need to do something extra. So for that, what we are trying to use is suppose that we consider a point. Suppose that we define 2 points to be not connected, provided that the function values at these points differ by a certain numerical value. So what I wanted to say is, suppose that we know that between x1 and x2 there is a possibility that between x1 and x2 there is a possibility that there is a discontinuity. In that case, what can happen is that discontinuity means that there is a gap. Essentially, it means that there is a gap. Of course, the meaning what I'm saying is not entirely correct, but okay, for the time being, let us assume that discontinuity essentially means that there is a gap in the function values at x1 and x2. So x1 and x2 in such a situation you should not connect. Okay, that's what essentially we want. X1 and x2 you should not connect in such a situation. But how much is the difference that we are looking at? Let us assume that if the difference is more than 0.5, just for the sake of testing, if the difference between x1 value and x2 value is more than 0.1, don't connect them. That's what we want. That's the instruction that we are going to give. Okay, I hope that I'm clear. If the difference between x1 value and x2 value in the x coordinates, if it's more than, if the difference between y1 value and y2 value corresponding to x1 and x2 is more than a given numerical value, don't connect them. That's what we want. Okay, so x difference, not x difference, y difference value. Let us keep that to be equal to 0.1 or 0.5 even, because in the case of the floor function, the value is actually 1. So if the function values differ by more than this, we will try not to connect that x1 y1 and x2 y2. That's essentially the logic is. Okay. Okay, now we are going to make use of something called a diff function. Okay, even before plotting, let us see. Let us try to see, to understand it properly, we should try to see all these things first of all. So print greatest integer coordinates, we'll try to see it in action. So what are the points appearing? So, and to understand it clearly, let us reduce it to say 3, otherwise too many points will be there. And even here, let us reduce it to say just 1. So the values, x coordinate values are 0, 1, and x coordinate values are 0, 0.1, 0.2, etc. up to 3. Corresponding y coordinate values are 0, 0, 0, etc., 1, 1, etc., 2, 2, 2, etc. Because 3 is not appearing here. Maybe I can put 3.1 here so that 3 also will be appearing. Okay, 3.1 is also kept. So 3 also will be appearing. So NP arrange also has the same property as that of range. The last value is not considered. Okay, the last value will not be considered. So now the greatest integer coordinates are now printed. Now there is a function in numerical Python. Okay, let us use that function. So that function is diff. So these are the values. Can you make out what exactly this diff is giving? This is 0. This is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th value is given to be equal to 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11th y coordinate minus 10th y coordinate. So 11th y coordinate minus 10th y coordinate. That's what the NP diff is giving. Okay, so the difference between consecutive values in this greatest integer coordinates is given by NP diff. I hope that it's clear to all of you. NP diff actually gives you, if greatest integer coordinates consists of a set of values, then NP diff gives the difference between I plus 1th value to the ith value, or I plus 1 minus I. That's what diff is giving. Okay, diff is giving I plus 1 minus I. Now, what we need to essentially locate is we need to find out the points where this one is occurring. The point where this one is occurring is see, this one value is essentially greater than this y difference value. So the y difference value that we can actually permit is this one value, not one value. 0.5 is the maximum permissible difference that we want to allow on the consecutive y values. Here it's 1. So to isolate this particular point, what we are going to do is we are going to check where the difference is exceeding this particular y difference. Okay, so those positions we are finding out. Discontinuous positions, NP where, not this command, NP where, numerical Python where. Okay, 1 second. NP where difference where NP different. Is greater than or equal to okay, what is this? Let's try to print this and see what is this exactly. So these are the discontinuity positions according to your definition. You see that? So what are the positions where the discontinuities are appearing? So this is the position 9, position 19, and position 29. Is that correct? Position 9, position 19, and position 29. Okay, let us see that. So 0 is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So at 9th position, the problem is happening. Okay, at 9th position, the problem is happening. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the 9th position, the difference is where NP difference greatest integer coordinates is greater than or equal to So 9 is appearing as the first one. Why 9 is appearing as the first one? Is the difference greatest integer NP difference is already printed. So it's here. So the value, okay, let me just suppress the previous things to see it clearly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the discontinuity is at this particular position. The discontinuity starts. I think you should interpret it probably like that. But even then, I think we need to just take this to one extra. I think we need to take. I think 10th position is where we should not permit the connection at the 10th position. Okay, the position is 10th, not exactly. We want this 0, 0, these two numbers, we don't want the connection. Okay, this is essentially what we want. These two y coordinates, we don't want any connection. Okay, these two y coordinates, we don't want any connection. Or otherwise, essentially, this number to the 10th number, there should not be any connection. 10th index. Okay, 1, 2, 3, no, 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, is it 9? Let me, I'm making some confusion counting. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's correct. So the discontinuity is happening at the 9th position. So the connection, so which values should not be connected? 9th position, that problem is there. Let us see the x coordinates also once again. Which two should not be connected? Where is that x coordinates appearing? Okay, let us take it. So discontinuous positions are now located. Which are those x coordinates? X coordinates are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at the 10th position, we don't want any connection. That's what essentially we want, right? 10th position, there should not be any connection. Therefore, position. So let us find out. Where. Let us take the. So this is 0 array. So how do we take out elements from this? How do we take out element from this? Can we add 10 to this? Sorry, can we add what do you call 1 to this so that the position can be advanced a little bit? Okay, otherwise let us see this. Do not take any such thing. Let us try to put. So what we are going to do is we are going to insert something. Okay, we are going to insert something into this x coordinates. So let us try to see that. X coordinates equal to insert 2x coordinates. What to insert? The discontinuous position. Where to insert? So to x at position this, we are going to insert NP. NaN stands for not a number. So if it's not a number, then no connection is possible. Not a number, no connection possible. Now, so if number, then only that Python will try to plot. Otherwise, it will not try to plot. Now let us try to plot it. How does this look? So x coordinates are now completely changed. I'm just trying NP insert. Insert must be one-dimensional or scalar. So this is two-dimensional. Therefore, let us take Needs to be one dimensional. Okay, I should fix that. Okay, since I think already the time is now crossed. So we will continue with this problem. I will try to finish this problem, and I will try to. There are some minor things, minor tweaks are required for fixing this problem. So essentially, what I wanted is the positions where the discontinuity is occurring, I would like to define such positions to be non-numeric positions, so that I can simply remove this those numbers from the plotting thing, so that those points will not be connected. That's what essentially I want. Okay, I'll try to fix that problem in tomorrow's session, and not only that, we will try to see how to define our own functions using which we can do this plotting. That also we will explain tomorrow. And let me just feedback form cannot be opened directly. There is a message. Okay, let me update this first. Or otherwise, I will update it tomorrow. In the Google Sheet, I will update this tomorrow. Till last program, it's updated in the Google Sheet. Okay, yesterday's Google document. That also I will provide. 1 minute. Yeah, yesterday's link is here. Now, what I want to essentially do tomorrow is finish two problems. One is that how to define our own problem, how to define our own function, and plot it. That's one thing. Even before that, we will finish this problem where plotting functions where certain discontinuities are there, so that that function will not be connected. The points will not be connected. So these two things we will once again take up tomorrow and finish plotting and move towards something in related to differentiation, integration, and all these kinds of finding limits, calculus related functions we will be taking up tomorrow. So if there are any questions, clarifications required on this, and I think already there was a question that how to change the label in the case of axis. That also I will try to explain tomorrow. Changing the position of axis labels, we will be explaining tomorrow. And by that, we will be stopping plotting tomorrow and starting differentiation integration related concepts tomorrow itself. And thank you very much for your patient listening. If there is any question, clarifications required, you may ask now. Thank you.
No questions. Today, any questions from the participants?
So tomorrow we have at 6 o'clock itself, right?
Okay.
Tomorrow's time is 6 o'clock once again, and we are going to finish the plotting by tomorrow, and we are going to start operations related to integration, differentiation kind of stuff tomorrow. Okay. Thank you very much.
Today's class is extremely interesting. I am sure that everyone has enjoyed this class. Thank you, Vishnu sir, for the excellent presentation. And thank you, all the participants. Tomorrow we will meet at 6 p.m.
Okay. Thank you.
Thank you all.